Welcome everybody to the Dr. Harris channel. I hope everybody is well. I've been waiting to see if anyone has any further questions before we can move on. So I don't see any further questions, so we're going to move on. So this is the outline of what we're going to be dealing with. We just got finished doing our signal transduction pathway for our Homer, if you will, our starting position signaling transduction pathway. Phosphoinositide 3 kinase, remember? PI3K? Okay. I would just like you to watch that one more time if you need to, because it's been a little bit of time and I need to make sure that we are still staying in the vein of seamless understanding. So you're going to have to make sure you're still comfortable and have a handle on the abbreviations and the vocabulary. Our next step now is going to be the insulin signaling pathway, which has its roots in the phosphoinositide 3 kinase transduction signaling, which is the reason why we tackled that first, made sure we understood it. Since, again, no questions were asked that need to be cleared up, we can move on. And I've waited a while before coming back to do the outline, just again to make sure we're seamlessly understanding our topics so that we can move on with a firm and comfortable and confident knowledge base that works. So far, so good. So now we finally get a chance to tackle one of our first maladies that I said we were going to do before, which was diabetes. So we're going to tackle diabetes and look at the two types that exist. I'm not going to be talking about the symptoms because everybody can look that up anywhere online on their phone, on the watch. You don't need me to do that. However, if there's a question based on what this video is talking about, the outline, or our next video, which is going to be our insulin signaling pathway, of course, ask the questions and of course I will answer them. So there's two types of diabetes. One is called type 1, and that was before known just as juvenile onset diabetes, because in that situation the pancreas beta cells are not generating sufficient amount of insulin. So there's no way for the cell to manage the sugar properly because there isn't enough insulin to do the job that's necessary. The second one is diabetes type 2, which was known before as adult onset diabetes. However, now it's just known as diabetes type 2 because children now present with diabetes type 2 as more of a commonplace due to things like obesity. So instead of it being just for adults, now is for both children and adults. So this is what we're dealing with now. In type 2 situation, your cells are saying, remember we did our initial videos about the cells, the cell organelles, and things of that nature. And we talked about at first our cell membrane because it's key. In that situation, you have your insulin receptors. They're the ones that are waiting for the insulin to come, and they're flaking. They're like this, waving like today, nah, maybe tomorrow, maybe now, not at all. So in that case, you have receptors that just aren't doing the job. So the insulin is there in sufficient quantity in the correct amount. So it's not a beta cell issue from the pancreas. It's the cell receptors, the insulin cell receptors that are like, I'm not going to be bothered with that today. Let somebody else take up this here sugar because, this insulin's not sticking to me. I'm not doing it. That's the situation. That's the reason why if it's not checked, you end up having to take insulin. So that's in a nutshell what type 1 and type 2 is going to be in regards to diabetes on the cellular level. Now, our video that you're going to see is going to take care of all the insulin. It's going to take care of how the insulin signaling pathway has its own sort of cascades after coming from its parent, which is our phosphoinositide 3 kinase, how that starts there and comes into its own with its own cascading abilities. So that's it in a nutshell as far as the dynamics for the cell. What we need to concentrate on is just, again, making sure you're firm with the vocab and abbreviations from before. And remember, I went over that vocab twice. We have one video just about vocab and abbreviations, and then we have the video that has our phosphoinositide 3 kinase transduction signaling pathway, and then I give you a brief review, brief run-in with the vocab quickly, and then we had the pathway presented. In this video that's coming after this one, it's just going to be the insulin signaling transduction that we're going to look at, the cascading and how it works, how the cell deals with type 1, how it appears in the cell with the cascading, what works and what doesn't, and then type 2, how it appears in the cell, what's working, what's not. And then after that video, we're going to have another video under the diabetes umbrella talking about a general consultation, clinical nutrition consultation on different things that can help the cells, assist the cells in proper sugar maintenance, because that is the problem in a malady like diabetes. The sugar is not being managed properly. It's not being checked and balanced in the way that it's supposed to, because remember, sugar is not the enemy. It's not oh my gosh, sugar is bad. Your body needs sugar. Brain, there are organs that require sugar as its fuel source. So it's not like, oh my gosh, sugar is the enemy. It's not. It's when you have it in abundance, then it's too much. Anything too much is not going to be worth its salt anymore. Everything has to be within a balance. With that said, it is also true that sometimes one person's normal range is going to be different than the broad spectrum range that we have in our medical books, our lab references. And this is true. This is not a false thing. I've had a couple of consults, and this was a concern, and it is true. Again, as I stated in previous videos, everyone's biochemistry is different, and that does need to be taken into consideration. I believe that an alert mind, an engaging mind, a conscious mind in regards to your health will help you and your healthcare provider give you the type of custom care that you're needing when you sit with your primary care physician or your specialist, because that's the role that they're in to help and support you, and you are in the same role to help and support yourself for overall health. So this hopefully will help with that, will further that, will confirm, and all of those types of things. So that's what the lineup is. This video, which just gave a very brief and simple, easy to understand explanation of type 1 diabetes from a cellular perspective and the type 2 diabetes from a cellular perspective. I'll recap really quickly. Diabetes type 1 is going to be when your beta cells within the pancreas are not manufacturing sufficient amount of insulin to deal with the body's sugar, maintaining the sugar level in the body, getting the sugar into the cells, and letting the cells do what it needs to do to manage the sugar and get the sugar where it needs to go in other places of the body. Diabetes type 2 is when your insulin receptors some of them have gone awry, and they're not all participating in the uptake of the insulin, so that the insulin can deal with the uptake of the sugar and then go into the cell and do the work that it's supposed to do. That is, in a nutshell, cellularly speaking, what diabetes type 1 and type 2 are. All right, so with that said, I look forward to your questions and concerns. We're going to have this insulin signaling transduction up shortly, so be ready, take your notes, and subscribe to the channel if you haven't already. Share with your loved ones, again, with anyone you think, feel, or know could benefit from this. Share it with them, all right? Be well until our next video. Thank you for viewing.